In this scenario, we're looking at the idea of the average number of basketball scholarships, and if offered to players who are over 6 foot tall, is greater than those for under 6 foot tall. So are you more likely to get a scholarship if you're over 6 foot tall as opposed to under 6 foot tall when we talk about the sport of basketball? They interviewed 50 colleges. They looked at 50 colleges. So both of my N values in this case are 50. And what they found was the average number of scholarships per school for those over 6 foot tall was 8.6 scholarships with a standard deviation of 3.3. And for under 6 foot tall, they only offered 7.9 scholarships with a deviation of 3.3. And now our question is there a difference here? Is the number for over 6 foot tall significantly greater for those under 6 foot tall? That's going to let us set up our null hypothesis and our alternative. In this case, it's important to notice that I made this population 1 and I clearly note it, and I make this population 2. When I set up my null, it's not going to be any problem because mu1 equals mu2. But now when I put in mu1 and I put in mu2 for my alternate, I want the 6 foots to be greater. So we're talking about is greater. It's going to be a one-sided test. Same as the one sample test, we set up our critical region. We're talking about a 10% significance level. So my critical value is going to be 1.28. I find my test statistic. I find the difference between the number of scholarships offered for over 6 foot and under 6 foot. I find my standard error, which would be the standard deviation divided by sample size plus standard deviation squared divided by sample size for the other one. This is going to give me a z-score, a test statistic of 1.06, which falls in my non-critical region, which means we're going to fail to reject the null hypothesis. In this case, since the null says that there isn't clearly greater the number of over 6 foot tall as opposed to under 6 foot tall, we can't conclude there's enough evidence here. There is not enough evidence to conclude that there's a greater number of basketball scholarships offered to over 6 foot tall athletes as opposed to under 6 foot tall.